rules. You know, a lot of people malicious intent with us, the lockpicking. But I mean, in reality, you go back even competitions at the World's Fair to, see about pick this lock. It's really only more modern this more malicious trend has happened. I mean, especially if a vulnerability is discovered in a lock now, they have to re-architect the entire assembly line, whereas before, just But in other words, I should say, to keep ourselves from that more malicious trend, we need to hold ourselves to a higher ethical standard. So because of that, well, there are ground rules. The first two kind of go together. Don't pick locks doors. This much should be relatively obvious. So the third bullet point on there is more to protect yourself. People do. There exists the possibility of breaking a lock when you pick. And if you're practicing picking, like your front door, well, there exists the possibility of you breaking that. And then you would have to call a locksmith, which generally costs a lot of money, and it's not ideal for anyone. So I highly, highly recommend you only pick locks, like all these on the table, that are purchased and used for the express purpose of practicing picking, instead of, a lock that you more rely on. Yeah?
So good. You see that?
I don't see anything.
Oh, yeah?
Here, wait. See what? Alright, so to a lot of information scared of people. You guys probably know what these are, right? Maybe? I don't know. A lot of info scared people do. Basically, these are magical boxes that sit on your network and try to keep bad guys from coming in. But the point is, if I have access to your facilities and I have this little light blue cable, well, I can wipe all your firewall rules away. There is no real protection against that once someone gains physical access. You guys know what these are, right?
Yeah.
What are they?
I took a picture of phone board.
Yeah. Telecom box. So, if I walk in your facility with a lineman's butt set and these cables, well, I can listen into any phone conversation going on inside the building. That has security implications, don't you think? And so, really, what this is getting at is all your hard work to, securing your network infrastructure from, the network side of things really just gets undermined by the guy going to Home Depot and buying your physical security hardware, because physical security really is kind of the trump card. It doesn't matter, huh? Yes, one of those, exactly.
He listens to your calls.
It happens.
Maybe.
So yeah, really it's just, if I have physical access to your systems, it's already game over. I can pull out the hard drives, I can load something directly in your computer. It just, that is the trump card. So physical security kind of matters a little bit too. So all these locks, whether they look like this in a, some sort of container, whether they look like that inside of a knob, or a padlock like this, all these locks, even though they look, fairly different from the outside, on the inside they're pretty much identical. So this is essentially what they look like. Is here you have the exterior housing of the lock. This is the interior core, or the plug. This is the thing that actually rotates inside. You have the keyway here, which is the way the key goes in. The keyway also typically has a couple little wardings here, and all these really do is they serve the purpose of preventing a key of one system from being inserted into another system, right? So if you have a Schlage door, you typically can't insert it into a quickset door, right? So if we slice this open, we can see the interior of the cylinder, and we can see the pin stack here. The pin stack is made up of 3 parts: a spring, a driver pin, and a key pin. Some people may refer to these as a top pin and a bottom pin. However, we're trying to get away from that, because especially you go over to Europe, and they're not mounted like this. They're mounted like that. So when you're referring to a top pin and bottom pin, they mean very different things to people, especially from Europe. So this is the driver pin, because it touches the driver, which driver is just another word for spring. And this is the key pin, because it touches the key.
Could have done this later.
So to represent this in a real life lock, same thing. You have the housing lock here, you have the interior core plug, You have the pin stack made up of the spring, driver pin, key pin. So as far as how these locks operate, if you're just to try to turn this cylinder, so I have this lock here, and I'm just going to get this and just trying to turn it. Obviously it doesn't turn, right? So what's preventing that? Well, it's just, these pins are physically preventing that lock cylinder plug from turning. We call that a binding action. So, when we insert the proper key, it raises this pin stack up to form what we call a shear line there. And what a shear line is it's when the separation between the driver pin and the key pin line up with a separation between the housing of the lock and the pin of the plug of the lock. When those separations line up, well, like I said, it forms that shear line right there, and then there's nothing impeding that lock cylinder from rotating, so it rotates. And then typically, there's a cam placed in the back which actually unlocks or locks the door. Again, to represent this in a real life lock, key goes in, raises the pin stack up to create that shear line right there. Once that shear line is then created, the lock cylinder turns, rotates, and then opens. So, of course, generally there's more than just a single pin stack inside these locks, at least I hope so. Typically, especially among the cheaper American lock, type of locks, you only really have the variation on these key pins here. All these driver pins are pretty much the same. And so, of course, the sizes of these key pins correlate to what we call the bitting of the key, or the code of the key. So, if you want to see how it works, the key goes in, these pins ride along this bitting of the key. When the key is fully inserted, that shear line forms all the way across the top of that cylinder. Once that shear line then forms, well, again, nothing is impeding the lock from turning and opening, and so it does. So if we have the incorrect key, looks like they're about to set off the balloon. Sorry. And it's off. Alright, so if we have the incorrect key, for instance, this second cut right here is a little bit too low. And so it'll be binding on just the tip of that driver pin right there. And that's enough to prevent that lock cylinder from turning and then opening. A little bit too high, same thing, except for it would be binding on that key pin there. Is this relatively clear to everyone? Anyone have any questions about kind of how a lock operates? Okay. So now that we know kind of how, a lock works, we can look at actually exploiting, certain vulnerabilities or whatnot and, essentially picking a lock open. So if you're trying to imagine the insides of the cylinder, say, I want to create a lock, right? I want to compete with Schlage and Kwikset and whatnot. And so, I draw up a lock design diagram in AutoCAD or whatever my preferred, SolidWorks or computer-aided design program is. I go, okay, I'm going to bring this to a manufacturer, have this made. And he goes, okay, well, what are your tolerances on this? And you go, tolerances? What is that? I just create it, and then you make it, right? Well, tolerances are essentially, how consistent things are that come off of the assembly line. So, you could have, even if you're aiming with, say, a diameter of 1 millimeter, you could have things coming off that assembly line at 0.9 millimeters or 1.1 millimeters. You have that variance, right? And of course, the higher tolerances that you have to use a much more expensive machine, which really factors into that process. And you go, okay, well, if you want to use the highest tolerances, this lock is going to cost a lot of money. You go, well, I want to compete with, Schlage and Kwikset and whatnot. Well, then we have to start cheapening the process, using a little bit less precise machines, using materials instead of just being, all steel or whatnot. We make it out of cheaper materials like brass or maybe even zinc. And so you keep making these compromises. I mean, if you're trying to imagine the perfect lock, all of these pinholes would be exactly circular right along this imaginary center line. And when you applied a light turning pressure, all the pin stacks would be binding at the same time, right? Well, in actuality, that's not the case. Because of these, cheapening of the manufacturing process and even manufacturing imperfections, this is all what adds up to make lockpicking possible. So if we look at this, this is a brand new lock that I took fresh out of the package. And you can see they did some sort of deburring mechanism at the tops of all these holes. And this is introducing these inconsistencies or these manufacturing imperfections. These pins, instead of being laser and cut or whatnot, you can see they were cast, and you can see there's little imperfections in that casting process there. I mean, it even can go down to, how often do you replace your drill bits out, right? Because every time a drill bit goes in, a little bit of wear is imparted on that drill bit. And it makes the next drill very, very slightly different. And so, there could be other aberrations, like these could be slightly ovoid in shape, a little bit off along this imaginary center line. But what all this adds up to is when I apply a light turning pressure to the cylinder, only one of these pin stacks is buying at any one time. I mean, kind of think of it as like the oddest one out. Say if I had 3 pins right here and here, and this one is back here, this one is here, and this one's here. Well, if you draw a straight line, this one would bind first, then that one, and that one, right? So then, like I said, this is kind of what adds up to make lockpicking possible. It's kind of like, you've all seen like the hacker movies where they go up and put a device up against a door and the numbers fly by and goes, okay, it's cracking, and then 2. And the next one, 4. Well, those of you who are more security professionals, you probably realize that passwords and door locks and whatnot are not really cracked like that, right? You take the whole hash, compare the whole thing with the whole thing. But lockpicking kind of works like hacking works in the movies, where you're only really working on one part of this cylinder at any one time. So to just see the general process, I mean, first we apply a light turning pressure, and then we enter in with a hook pick or a half diamond or your preferred lifting tool, and we just go in and lift this pin stack up. And so I'm going to be talking about a few things that you may feel or see or hear even. Don't be afraid when you're going and practicing that you're not feeling these things. This is just, this is why lockpicking takes a lot of practice, right? Is you're kind of training your fingers to feel these things. So what will actually happen is when this gets set to shear, this plug will rotate a very slight amount. It'll rotate enough to form a little lip here for this key pin to kind of rest upon, driver pin to kind of rest upon. And then the key pin will then be free to fall back down or do whatever gravity tells it to, right? So, after this happens, it basically moves on to the next driver pin. And so when we actually look at picking this, we insert the tension wrench, or tension tool, apply that tension pressure, that turning pressure, and we can see here that this is the binding pin stack. Of course, we don't know this when we're just going in and trying to pick this lock. But we're going in with our hook pick here and are kind of feeling around. Again, it may not be immediately perceptible to you, but the binding pin stack actually will be slightly different to lift, a little bit harder to lift. Because think about it. I mean, friction is being added to the whole process. You have the housing lock that wants to go this way, and the core of the lock that wants to go this way, and they're just, they're actively pressing against both sides of that. So it's adding friction to the whole process, makes it a little bit harder to lift. But again, don't be afraid if you're not actually feeling that when you're first starting out. So essentially we just repeat that process, hunting for that binding pin all throughout this lock until all the pins are picked and the lock opens. So, anyone have any questions on that?
He's got Python.
Alright. So to go a little bit more into some details here about how things actually work and whatnot. What we were talking about here is what's called lifting picking or single pin picking. This is generally the thing you want to try to practice with, because this is the thing that is much more skill based. It's as you will get better and better, you'll be able to pick higher and higher classes of locks like this. There is another technique though called raking, and this is usually what the tools that have like a little squiggle or some sort of odd shape that isn't, just a single lifter or a single thing. Basically, those are rakes. So how raking works is it's a much more luck-based activity. We insert the tension tool, apply that turning pressure, and then we just go in here and we're just kind of raking around, varying angles, kind of moving up and down, and hopefully by luck, it's picked open. And so the thing about raking is if it's going to work, it's typically going to work relatively quickly, right? And so it is a much more luck-based attack rather than skill-based, which is why a lot of people just starting off really, take to raking. Because hey, with raking I can open locks. But the thing you'll find with raking is, especially when you get into the more difficult levels of locks, especially when you get into security pins and tighter tolerances and whatnot, raking becomes much less effective. I mean, in competitions, it's still the first thing I try because if it's going to work, it's going to work quickly. But single pin picking is really the thing you want to practice to get to that higher, more advanced level of picking. So a little bit on tension tool usage. So first off, a lot of people, well, I should do a standard disclaimer here. I'm going to be talking about a few things that, I find work for most people. Don't be afraid if it doesn't work for you. Lockpicking is all about practicing and trying different things and finding out what works for you. So when I'm talking about things, feel free to try different ways, because if you find something that works for you, awesome, use it. But this kind of, gives you a little bit of a starting off point. So generally I don't like to tension with my thumb because I find I get a little bit less control over that. And so generally I want to use my little pointer finger here. Now here, I probably still want to pick like this because I find that when you pick with your finger up here, you have, a little bit less control over it. So if I insert this like that, here I have much less control over the variability of that tension pressure than I do, much more out here. So I kind of recommend kind of stretching it out there. Now we're still not quite there because you notice the finger is turning white, which generally is an obvious sign that you're putting way too much pressure on that tensioner. It really does not require much. I mean, in fact, if I just have a lock in here and I have the proper key, well, it turns really easily, doesn't it? And so really it's just, I equate it to, roughly about half the amount to press down on one of those laptop keyboards. Imagine the weight of 3 butterflies at the end of it if you're a more visual learner. It really does not require much though. In fact, you'll probably find that when you're pressing picking and it takes you a while to get the lock, but you can still get the lock. Try it again with a little bit lighter tension pressure on them. And you may even have an easier time with picking it. So like I said, it's very obvious when your fingers start to turn white, so you take your finger away and you have this line across your finger. That's a very clear indication that you're using a bit too much tension pressure. So, there are 2 main considerations when you insert your tension tool into the into the lock. The first thing is you don't want to put it all the way at the bottom. Because if we put it all the way at the bottom, well, this piece of metal here will essentially be grinding up against the housing of the lock here. And that will add friction to the whole process and make things a bit more difficult to pick open. Secondly, you want to have enough room up here to be able to insert your tension tool and maneuver around. Because if you don't have that room, well, if I have my tension tool like this, I have no room to go in there with a tool and actually manipulate the individual pins. So there are those main considerations. There's a lot of people have tools. Feel free to share. I think I may have some for public use as well. I have a number of locks out here that you want to kind of start with. They have numbers on them. Those numbers indicate how many pins are within the cylinders. So, a 1, for example, will have just 1 pin in there. You want to start off with that, keep on going to a 2 and whatnot. One thing about the 1-pin lock, actually, why I want to start out with this is more just to learn how things feel, because it doesn't really require much to get this open. I mean, I could just take a tension tool, insert it like that, lift that single pin up, and the lock picks open. And so, really, it provides no real challenge. You'll be able to pick it open very easily. It's just, the big thing is learning how things feel. So, first off, don't even insert the tension tool inside the lock. We can just take this lock, take, say, a hook pick, and just feel this lock. So what we're feeling here, since there's no tension pressure on there, is just the pressure of the spring pushing down there, right? So this is kind of more how a non-binding pin feels. Now we can take the tension tool, insert it into the lock, apply a light turning pressure, and since there's only 1 pin stack in the lock, we know that that is the binding pin stack, right? And so this is kind of how it feels when you're working with the binding pin stack, and then when you get that pin stack up, pick the shear, and then turn it open. So feel free to try it out. There's lots of locks out there, and if you have any other questions, let me know. Thanks.